Welcome back. Today is the last episode of the propose of high level design of the rate limiter. Today we'll talk about the high level architecture and where we will store the counter basically. Just a minute. High level architecture. Okay, so first of all, if you didn't watch the previous videos, I highly recommend to watch them. If you watch them but you need a quick review, just make like 6-7 minutes review, so you will understand what we are building and where we are going. So basically, today we have basically this is one of video of our series of design a rate limiter. Basically, in the previous videos we talked about the understanding the problem and most of the proposal of high level design, and basically when we are as always when we are in a system design interview, all the time the question is vague, and our duty at the interviewee is to make sure that we put as much as clarifications as possible, so we understand what we are building, we understand the functional requirements and non-functional requirements. And basically we have a framework that we put our design in. So basically we understand the problem, we propose a high level design, we get a deep dive on it, and after that we wrap up. And we started with understand the problem, and when you understand the problem, you just have like 5 to 10 questions, depends on how big the question is basically. So basically one of the question is what types of the rate limiter we have. It's a API one. Does the rate limiter work on based on IP address or user ID? It works with both basically. It should be flexible. What is the scale? And are we talking about the distributed system? Yes, we're talking about the distributed system. The other one, should the rate limiter response to the user that being blocked? Yes. And are there any performance or latency requirements are needed? Basically, the rate limiter should not make any HTTP request too slow, so we have super low latency. So from this questions, we get to our estimation of the functional requirements and non-functional requirements. The rate limiter must be able to limit the rate of the request for specific type of requests. The rate limiter must respond to the user when the limit is exceeded. The rate limiter must be able to track the rate in real time. The non-functional requirement, basically the rate limiter must be high available. The rate limiter should have low latency, high fault tolerance, and use as little memory as possible, and also it's a distributed system. However, it's really important that after we put the functional requirements and non-functional requirements, we will ask our interviewer, is there anything I'm missing? Is there anything I'm missing? Do you want to add another functional requirements? Do you want to add another non-functional requirements? Because we want to design the things that the interviewer wants, or anything there that I put that doesn't need to talk about, things like that. So all the time we ask for clarifications. Like the key of the system design interview is that you ask on clarifications all the time. And after that we finished the understand the problem. So we started with the proposal of the high level design, and basically we started with two things. We had first thing that we have, where should we put the rate limiter, and second thing, which algorithm that we use. The first one, where should we put the rate limiter, we have two solutions, in the client side and the server side. The client side could be quite problematic because we don't have a full control of the client. So maybe we will not, like a lot of behaviors that we doesn't expect we will face basically. And the server side, I guess it's more recommended because we had a control of it. But we have two things also. It's that in the server side there is two ways to implement the rate limiter. One of them is to put it in the API gateway. The other one is to put it in the API servers. And in the which one of them? depends on the actual needs of the application. So basically, the most popular way is to use it and put it in the API gateway, because it's a distributed system. So that, like, there is a high chance that the system using a microservices architecture. If the application doesn't use a microservice architecture and the technology doesn't support that, we just added it to the API services. We have, after that, we discussed the tokens, and I guess I will not talk about the tokens because we have like 5 videos talking about each token and in details. So basically, just feel free that I will you have a bucket token, leaking bucket token, fixed founder token, sliding fixed window counter, and slide window log and sliding window counter. Just feel free to watch the video so you'll understand each one of them. And also for each one of them, I just make a quick review so you understand everything. So you just can skip the first 5-6 minutes if you want. And after we talked about the algorithm, that we talked about the today's video, that we should talk about, okay, from basically the idea of the algorithms that we have here is simple. The high level, at the high level, basically we need a counter to keep track of basically how many requests are sent from the IP address to the user, or like from the client, etc. Basically, so basically, if the count and also if the counter is larger than the limit, the request is disallowed. So basically, let's just take this one and let's just wanna put it here. Okay, so yep. Okay, so basically, we have this one, and basically the idea of the algorithm is pretty simple. But we have counter, and we compare this counter basically to the limit. So basically, where shall we store this counter? Basically, one of the things that we talked about that we should the rate limiter should be able to respond in real time, and the second thing, we should have low latency. So if we used a database, basically it will not be a good idea due to basically to be quite slow, because we are storing our data in disk access. So I guess the better solution is to go with the in-memory cache, basically because it's so fast and supports basically time-based expiration strategy. So it will be way more easier for us. So basically, for instance, we could use Redis, and basically let's just go back with this one. Okay, so basically we could use what we said, yeah, we can use Redis, because it's basically a popular option to implement basically a rate limiting. It is basically Redis is an in-memory cache store. Basically, it's a memory store that offers 2 commands. We have the increment and the expire. So basically, let's give me a minute here to type both of them. We have the increment, and this basically it's increases the store by 1, and we have another one that called expire. This one, it's set time out for the counter, basically to be deleted. And basically, let's just make here a good. So basically, let's assume that we have the client, and let's say that we have a rate limiter middleware. We have a rate limiter middleware, and wait a minute, middleware. There is additional W. And basically, the client send the request. Just delete that. No, delete, and delete. And I just assume the API servers. I'll just make it. So basically let's just make the API servers looks better. So let's add, no, let's copy this one and paste it again. Copy and paste. Yeah, okay. No, go back. And that's, yeah. And so basically it will be, I wanted this one to be smaller, so it will be like that. Okay, and I want to copy this one and paste it again. I want it to be smaller, and paste it again, and I want to be a little bit smaller. And basically, yeah. So basically we have here our web servers. Just make it like slightly bigger, this one. Okay, so basically we have here our here we have our API servers, and we have here our let's just make this one as big as the rate limiter middleware, and we have the client, and basically we have the Redis. Let's put shape here of the Redis. Okay, I want to have no color. It will be Redis. So basically it will be like that. So the client will access, will send the request. The request will go to the rate limiter, and basically when the request went to the rate limiter, it goes to Redis. And can I make this a dual one? How can I make it a dual? Because I guess there is a dual one. No, I wanna how can I make this one a dual? Okay. Okay, I guess I don't know how to make this one a dual one, so basically I'll just send another one again, and it sends basically it sends back the request, the response to the middleware. Depends on the requests, we can't access the API servers. So this is how actually it works basically. And basically the client sends the request to the rate limiting middleware, and basically the rate limiting middleware fetches the counter from the corresponding bucket in Redis, and they check if their limit is reached or not. If the limit is reached, the request is rejected. If the limit is not reached, the request is sent to API servers. Meanwhile, the system increments the counter and saves it back to Redis. And basically that's it. And in the next video, I guess we will go a deep dive. So basically we'll talk about the rules, and we'll talk about the headers. And we just put we could, if we got lucky, we could put like a detailed design, and maybe we could talk about some of the problems that we can face basically. And that's it for today's video, and hope you like it. And if you like it, make sure to subscribe to the channel and hit the notification bell so you will never miss a video. And that's it for today's video, and see you in future videos.